Okay, welcome to day number 4. Today we have 2 warm-ups. So take a moment to copy these down, pause the video, and actually try them first. So you should be able to do this. This is just a strict review from yesterday's lesson. Warm-up number 1 is we are factoring where possible. So I'm going to go through a bunch of my different factoring strategies. When I look at the first question, it's a simple trinomial. I can tell because there's a 1 in front of the x squared. And my simple trinomial factoring is to try to find something that multiplies to the last number, 72, and adds to the middle number, negative 17. Don't forget to take that negative sign with it. So I go through all the pairs of numbers that multiply to 72. I want to multiply to a positive number. So something like 8 times 9, that would give me positive 72. But when I add them together, I get positive 17. In order to make it multiply to a positive, I could also have a negative times a negative. So as long as the signs match, I'll end up with a positive product. And then when I add them together, I get negative 17. Don't forget, for simple trinomial factoring, I'm just going to put the x's right at the front of the brackets. That gives me back my x squared when I FOIL it out. And then I just pop those two numbers into the end of the brackets. I could check my answer by multiplying that back out. Next, I move on to the second question, part B here, and I notice it's not a simple trinomial. There's a coefficient in front of the y squared. So I check for a couple things before I get started. The first thing I check for is there a common factor that I can divide out of everything? And there's not. And then the second thing I check for is the first term and the last term, are they both perfect squares? So the last term is a perfect square, but the first term has a coefficient 6, not a perfect square, so I can't use my perfect square trinomial trick. I need to use decomposition, which tells me I'm going to leave the first term the same and the last term the same, and I'm going to decompose or split that middle term into 2 terms. So I'm hoping to come up with a factoring by grouping the 4-term split. In order to come up with what I should split those middle terms into, I ask myself, what are 2 numbers that multiply to the first number times the last number? So my first number is 6, my last number is 9, so I need to multiply to 54. And then I need to add or have a sum of positive 29. So I go through all my possibilities for this, and I see that 2 times 27 gives me 54, and 2 plus 27 gives me 29. So instead of writing 29y on my line, I can say that's the same as positive 2y and positive 27y. Doesn't matter what order I wrote those in, I could have swapped in, but the 27 first. Now that I have 4 terms, I can factor by grouping the first pair and the last pair. And I'm just looking for a common factor in each of those pairs. I see that I can take a 2y out of the first 2 terms, and of course I'm dividing it out. I'm left with 3y plus 1 when I divide both terms by 2y. And then looking at the second pair, I can divide both of those by 9. And again, when I divide both of those by 9, I'm left with 3y plus 1. So now I have a common factor or a common bracket of 3y plus 1. I'll bring that out front, and then I write the leftovers in the next bracket. So my leftovers are 2y plus 9 when I divide that out. And I can check my work again by FOILing or multiplying that back out. In part C, I only have 2 terms, so that reminds me of difference of squares. I do see that it is a difference because there's a subtraction sign between them. And then I check if they're both perfect squares. 16 is a perfect square, 144 is a perfect square, and a squared is a perfect square. So I'm going to use my difference of squares trick that tells me that I get 2 different brackets, and I just take the square root of the first thing, 16. Square root of 16 is 4. I put that at the front of each bracket because it was first. And then the square root of 144 is 12. The square root of a squared is just a. So I put that square root at the end of each bracket. And then I should have 2 different brackets for difference of squares. One of them needs to be subtraction, and one of them needs to be addition. That way when I multiply it out, my 2 middle terms will cancel out, and I'll be left with a negative 144a squared. Taking a look at part D here, again, I see that there's a coefficient in front of the x squared, so I'm going to check for a common factor. I don't have one here. And I also check to see if the first and the last term are both perfect squares, and they're not. Now, it might throw me off a little bit that there's a y squared at the end there, but I just want you to remember that really I just need my last 2 terms in the brackets to multiply to give me that y squared. That tells me that the last 2 terms are each going to have a y. Y times y would give me the y squared. And I'm not going to worry about it too much for now. I know I'm using my decomposition strategy. So my first term stays the same, and my last term stays the same. And I'm just going to split the middle term into 2. So I'm just ignoring the y squared right now. I don't really even care. I go off to the side and I'm asking myself to find 2 numbers that have a product of the first number times the last number. Be careful to take the sign with it. So I have 8 times negative 15, and that's negative 120. And then I want those 2 numbers that I come up with to have a sum of 2. So I go through all my possibilities of numbers that multiply to 120. I see here I could use negative 12 and positive 10, or I could swap the signs on that and use positive 12 and negative 10, and that way I'm multiplying to a negative answer. And I see that that second pair there would add up to 2, so that's the pair that I want. So I take the 2xy, and I'm going to change the coefficients. So now instead of 2xy's, I have 12xy's, take away 10xy's. And again, I don't care too much about the variables at this point. I'm just splitting it up. Now I have a group of 4, so I'm going to split it and factor it by the 2 groups. The first group, I see that there's a common factor of 4x, and when I divide that out, I'm left with 2x plus 3y. And then I take a look at the second pair, and I see that there's a common factor of 5y. Now I want to ask myself, should I take the negative sign or take a positive 5y? And my goal here is to have everything in the bracket match the first bracket. So I want this stuff in the brackets to be positive. That tells me that I should divide out the negative so that it goes away. So now I'm taking negative 10xy, dividing it by negative 5y, and I'm left with positive 2x. And then I take the negative 15y squared, divide by negative 5y squared, and I'm left with positive 3 and just 1y. And this is good news because now my 2 brackets match. That means I can pull them out front because they're in common. And then write the leftovers. After I divide out that bracket, I would be left with a 4x and a negative 5y. I could check my answer by multiplying that back out. So warm-up number 2 has taken us back to some arithmetic in fractions. So take a minute, copy this down, and see if you could figure out what these guys equal. Pause the video and restart it when you're ready to go. So I'm going to do each of these questions in a different way. I'm going to do one using my BEDMAS, so thinking about I need to simplify the numerator and simplify the denominator before I do the division in between. So the first time that I do this, multiplying the 2 top numbers I get 6, and multiplying the 2 bottom numbers I get 16. And then we always reduce to lowest terms, so I can say that 6 over 16 is the same as 3 over 8. I just divided them both by 2. So I'm looking for some shortcuts here. Instead of having to multiply everything out and then divide out a common factor, I want to do it in the opposite order. So when I look at the original question again, so I'm going back and taking a look at my original question, I'm looking for a common factor on the top and the bottom. So I already have a 2 times on the top and a 2 times on the bottom. That tells me that I could get rid of the common factor. 2 over 2 is the same as 1, and I'm just left with 3 over 8. So there's a little bit of a shortcut there. If I can write it factored, that means write it as multiplication, I can cancel the common factors before I multiply. Taking a look at part B, again, I could do the arithmetic first. So doing the arithmetic in the numerator, I get 5, and in the denominator, I get 10, and we know that that reduces to 1/2. Now take a look back and ask yourself, is there a shortcut for me to get to that 1/2? And here there's no common factor. There's a common additive of 2, but that is not the same thing as a factor. It's not how we reduce to lowest terms. We reduce to lowest terms by dividing the whole thing by the same number. So I cannot do any shortcuts. This is not the same as just canceling out the 2's and calling it 3/8, right? That would not work. That's not the same as 1/2. So I can't use any shortcuts. In in part C, again, I could use just straight arithmetic. I know that when I multiply two fractions, I multiply across the numerators. So I get 20 times 9, and then multiply straight across the denominators, 27 times 4. And then I could reduce this to lowest terms, and I would end up with 5/3. Now, there's some shortcuts here that I could use instead. Because it's multiplication between the two fractions, I can cancel from the top to the bottom. And I can go from the top to the bottom within one fraction or across two fractions. So I'm actually going to go across the fractions. And 20 divided by 4, I can reduce that. So 20 over 4 is the same as 5 over 1. And I can reduce those. And then going the other way, I've got 9 over 27. That's the same as 1 over 3. So in this case, I'm just reducing to lowest terms first. And now I multiply across the top. 5 times 1 is 5. And multiplying across the bottom, 3 times 1 is 3. And I end up with the same answer. So shortcuts exist when I'm multiplying, either within the fraction or between two fractions. So getting started on today's lesson, we're simplifying and evaluating rational expressions. So remembering, what is a rational number? A rational number can be written as a over b, where a and b belong to the set of integers. So that funny z is the set of integers. Remember, integers are like -3, -2, -1, 0, 1, 2, 3, and counting from there. And b, of course, cannot be equal to 0. I can't divide by 0. Similarly, a rational expression can be written in the form p at x over q at x. So before we were talking about just rational numbers, a number on the top and a number on the bottom. Now we're looking at rational expressions. So it means I'm going to have some sort of algebraic expression on the top and on the bottom. So p at x and q at x are both polynomials. And of course, the q at x one, the one on the bottom, cannot be equal to 0. So we'll take a look at an example here. Here are two different rational expressions. X plus 1 over x, that's a rational expression. Or x minus 3 over x squared plus 2x minus 4, that's another rational expression. So I'm going to evaluate both of those two different rational expressions for x equals 3. So just making sure that we can substitute this in and simplify it numerically. So if I'm evaluating for x equals 3, that means I'm replacing each of the x's with 3's. And then from there, I'm just going to subtract in the numerator and subtract in the denominator. I know that there are no shortcuts if I'm subtracting or if I'm adding. So I just need to do the subtraction and do the subtraction. And then I can simplify this. -1 over -4 is the same as +1 over 4. Moving on to part B, again, I'm substituting in x equals 3. And then the bottom has subtraction. So again, I can't use any tricks here. I actually just have to figure out what it equals. So 3 on the top, and then on the bottom here, I get 9 minus 3 minus 6, if I do that exponent first. And that simplifies to 3 over 0. Now, I can't divide by 0. So I know that this expression would be undefined. So that in blue writing is sort of what I'm thinking. And then on my next line, I would just say that this is undefined. If you type it into your calculator, you're going to get error. Don't write down error. This expression does not equal error. This expression is undefined. So make sure you're using the proper language. So for values of x that make the expression undefined, we state restrictions on the variables. So in that last example, x equals 3 was a restriction for that rational expression. Restrictions come from where the denominator equals 0. Sorry, I lost my spot here. So for example 2, we're just going to state the restrictions on each of the variables in each of these cases. Remember, those restrictions come from whatever number would make the denominator equal to 0. So what I want in part A is to make sure that x plus 5 does not equal 0. If it equals 0, then I'm going to get an undefined expression. So if x plus 5 cannot equal 0, then that tells me that x cannot equal negative 5. In part B, I've got 7 over a. Well, the denominator cannot equal 0, so a cannot equal 0. That one's a little bit simpler. For part C, I've got something times something in the denominator. So what I know is that x minus 2 times x plus 6 cannot equal 0. Now the only way that's going to happen is if the first bracket equals 0 or if the second bracket equals 0. So I know that x minus 2 cannot equal 0, which tells me that x cannot equal 2. And I know that x plus 6 cannot equal 0, so that tells me that x cannot equal negative 6. Both of those numbers would give me an undefined expression. Taking a look at part D, there's 2 variables in this question, but I don't really care about the n variable when I'm thinking about restrictions. When I think about restrictions, I'm only looking at the denominator, so I know that the denominator 3m minus 2 cannot equal 0. And then I just solve this so it looks like m equals a number, or m does not equal a number. I get to follow the same rules as I would if it was an equal sign. So I'm going to add the 2 to the other side. And then I'm going to divide both sides by 3. So here, if I subbed in m equals 2/3, I would get 0 in the denominator, and this would be undefined. For our next example, we're going to simplify each rational expression and also state restrictions. So this is kind of like our warm-up, our second warm-up, when we were trying to find factors that would cancel so that I get a simpler answer. So thinking kind of like lowest terms when we used fractions in elementary school. So here I've got 2x over 8x squared, and I'm looking for a factor that I can cancel on the bottom and the top. So first I look at the coefficients, and I've got 2 over 8. I know that I can reduce 2 over 8. That's the same as 1 over 4. So I've already simplified my my coefficients, and now I'm going to look at my x's. I've got 1x on the top and 2 x's on the bottom. I can reduce that by dividing out 1x from the top and 1x from the bottom, and I'm left with 1 over 4x. I have some restrictions here though. So here my restriction is that x cannot equal 0. I got that restriction by thinking about 2 different things. So normally I wouldn't write this stuff in red, but what I was thinking about is that 8x squared can't equal 0. And then I can solve this for x. So I divide both sides by 8, and I get that x squared can't equal 0. And then I take the square root, the positive and negative square root of both sides. So I get x is equal to, the square root of 0 is just 0, and positive and negative 0 are both just 0. So in that case, I get x cannot equal 0. So I'm going back to the original question for that restriction. Looking at part B, I'm going to do the same thing. I'm simplifying, and when I simplify, I'm looking first at the coefficients. 27 over 9, that's the same as 3 over 1. You can write the 1 in the denominator, but you don't need to. And then I look through my x's. I have 3 x's being multiplied on the top, 1 x on the bottom. And when I divide out that x, I'm left with x squared on the top. 2 y's being multiplied on the top, 1 y being multiplied on the bottom, so I can divide out 1 y from the top and the bottom. And I'm left with 3x squared y over 1, or just 3x squared y. Again, I go back to the beginning, the first denominator, to think about what would make that equal to 0. Now there are 2 different variables in that denominator. So I have 9 times the x number times the y number in that denominator. So thinking about my restrictions, if x was equal to 0, I would end up with a 0 in the denominator, an undefined expression. So that's not okay. And same thing for y. So x and y both cannot equal 0. Moving on to part C here, we're getting a little bit trickier Because when I look at C, there's subtraction in the numerator and subtraction in the denominator. And we saw in our warm-up, I cannot cancel. I can't cross things off or reduce to lowest terms when there's subtraction. So this is the number one mistake that still my calculus students are making. You cannot cancel across subtraction. So what I need to do first is change the top so it looks like multiplication. And how do we do that? Factoring. So this is why that factoring lesson is so important. You need to go back and make sure that you know how to factor. That's going to make it multiplication on the top and the bottom, and then I'm allowed to cancel. So factoring out the numerator, I'm just looking for a common factor here, and I see that they both have an a, and then I can divide out the a, and I'm left with 2b minus c. And then in the denominator, I see that they have a common factor of 3. I can divide that out, and I'm left with 2b minus c. And now what I have is a times a bracket in the numerator, and 3 times the same bracket in the denominator. Because the whole bracket matches, I can cancel it out. Something divided by itself is just equal to 1. So now I'm just left with a over 3. Don't forget to go back and look for restrictions. Your restrictions come from where the denominator equals 0. So I'm going to use my factored form instead of looking at 6b minus 3c. My factored form says 3 times something cannot equal 0. So the something, 2b minus c, cannot equal 0. I can simplify this expression by moving the c to the other side when I add it over there. What I end up with is that c cannot be twice as big as b. That's my only restriction for that. So taking a look at D, same problem as the last example. I have subtraction in the numerator and subtraction and addition in the denominator. So I need to simplify this first. I'm going to factor that denominator at the top. I cannot factor. I can put some brackets around it so it looks like a factor. When I look at the bottom, I'm asking what two numbers multiply to 20 and add up to -9. And so I can see that -4 and -5 are those two numbers. You might need to go off in your rough space and do a bit of work there. Now what I see is I have a common factor or a common bracket on the top and the bottom. I can cancel those out as soon as it's multiplication. That leaves me with a 1 in the numerator and a minus 5 in the denominator. Again, to come up with restrictions, I'm going to look at the factored form of my denominator before I cancel things. That factored form was a minus 4 times a minus 5. That tells me that neither one of those brackets can equal 0. So a cannot equal 4 or 5. That would make the whole denominator equal 0. Moving on to part E. Again, I have addition in the numerator and in the denominator. So that's not great. I can't cancel if there's addition, and I want to try to simplify this. When I look at the numerator, I can factor it. I'm looking for two numbers that multiply to 9 and add up to 6. Those two numbers are 3 and 3. So I'm just going to write the bracket squared because I know that they're both matching. In the denominator, I want two numbers that multiply to 3 and add to 4. So 3 times 1 or 3 plus 1 would work. Now again, I see that I've factored the top into brackets times brackets, so I can start canceling. I have an x plus 3 on the bottom, and it'll cancel out one of the x plus 3's in the numerator. So that leaves me with an x plus 3 over an x plus 1. For restrictions, I need to go back to the beginning, but I'm going to take a look at the factored form of that first denominator. It was x plus 3 times x plus 1, and that tells me that x cannot equal -3 or -1. Don't forget you should be listing your restrictions in order from the smallest number to the biggest number. Moving on to part F, this one's a little bit trickier because now I don't have simple trinomials in the numerator and in the denominator. So I might need to go off into my rough work to factor those numerators. So I'm going to think about decomposing the 8x and then decomposing the 17x. So I want you to pause the video, go off into your rough work and factor those. Coming back, you should end up with x plus 3 times 3x minus 1. And again, I would check my work by multiplying that back out. I can already see that I'm going to get the 3x squared and the minus 3. My middle term will come from x times -1 and 3 times 3x, so that will give me the 8x. And then in the denominator, when you went off in your rough work and factored this, you should have gotten x plus 3 times 6x minus 1. So again, I can see that there's a common factor or a common bracket that cancels top and bottom, and I'm just left with 3x minus 1 over 6x minus 1. Much simpler than what I started with. I just need to remember to state restrictions, including the bracket that I canceled. So here I can see that I need to make sure that x does not equal negative 3, that's the bracket I canceled. And then imagining what number would I need to sub into 6x minus 1. I know that that can't equal 0, so this is just kind of off into my rough work. I notice that 6x then cannot equal positive 1, and dividing out the 6, x cannot equal 1/6. So I'll add that to my list of restrictions. And our last two examples here, in G, again, I've got that coefficient on the x squared, so you're going to need to pause the video, decompose the 11x, factor it out by grouping it, and then on the bottom I notice that it's a difference of perfect squares, so I can use that trick for the bottom. Pause the video, go and do that rough work. Coming back, you should have 3x plus 1 in the numerator and 2x plus 3. And then in the denominator, taking the square root of the first thing and the square root of the last thing, I put that at the front and the back of each bracket. One of them needs to be positive and one of them needs to be negative. If you're not actually pausing the video and doing the work yourself, then you're not doing the learning, right? Which won't help you when it comes to test time. So now I see that I have a 2x plus 3 bracket on the top and the bottom. I have to cancel the plus 3. The negative 3 would not cancel if that's all that I had. And I'm left with 3x plus 1 over 2x minus 3. Again, looking for restrictions, I'm looking at my original denominator before I canceled. So I can see there that I had 2x plus 3 cannot equal 0. And I also had 2x minus 3 cannot equal 0. So I'll simplify both of these. I'm going to move the 3 to the other side by doing the opposite operation, and then divide out the 2. And then same thing with the other guy. So I have two restrictions. All right, on to our last example. Looking at the numerator, I notice that there's a common factor. So there's a common factor of 3m. I'm going to take that out. And then taking a look at the denominator, I also notice that there's a common factor of m. So I'm going to pull that out front. And now I'm going to try to factor that leftover bracket in the denominator. It still has a squared, so I think that maybe I can make that a little bit smaller. The numerator is not changing. When I look at this one, it's a simple trinomial, which is nice. I'm just looking for two numbers that multiply to positive 4 and add up to negative 2. And so I get the same bracket twice, m minus 2 squared. I can see lots of stuff that I can cancel here. So on the top, I have 3 times m times a bracket. And on the bottom, I have m times a bracket times a bracket. So because I have an m multiplier in the top and the bottom, I can cancel both of those. And then because I have the bracket multiplier and the matching bracket multiplier on the bottom, I can cancel 1 from the top and 1 from the bottom. That leaves me with 3 times 1 on the top, so just 3. And then on the bottom, I've got 1 times m minus 2, so m minus 2. Much simpler than what we started with. Now we're going to state our restrictions. So again, I'm going to take a look at my factored form. So I'm thinking about I had m times a bracket when I had fully factored. That tells me that the m cannot equal 0. So that came from this guy here. And then I have to think about, well, those two brackets, I need m minus 2 cannot equal 0. And so that tells me that m cannot equal 2. So therefore, my restrictions . All right, homework is posted on the website. Have a good day, guys.